Hello students, welcome all of you at AriserTalent. So what we were discussing about the questions related to your chapter Light, that is the first chapter of your class 10 physics. And in our previous lecture, we have a discussion about the NCERT questions. Now, we are going to start with NTSE question that is very important from your NTSE and other Olympiad exams you are fighting for. So, let's start with the NTSE questions in this sequence. So the first question in this sequence is a mirror which can produce a magnification of +1. So mirror is going to produce a magnification of +1. Mirror is producing a magnification of +1. Then what will be the mirror? It will be convex mirror, concave mirror, plane mirror, yeah, both concave and plane mirror. So if the magnification is +1 produced by the mirror, then the mirror will be plane mirror we have. So the plane mirror is going to produce a magnification of +1. So which option is correct here? We can found that option number C will be our correct. So the mirror which is going to produce a magnification of the +1 is our plane mirror. So the next question is, when light travels from medium X to Y, you can see that a ray of light is going to be incident from medium X to Y, then you have to choose out the correct option. Both the speed and frequency decrease. So, the frequency of the light when traveling from one medium to another is not going to change. So, this is a wrong option we have. Both speed and frequency increase. Frequency will have nothing to do with any change while traveling from one medium to another. Both speed and the wavelength decreases. This is the correct option. When a light is going to travel from one medium to another, you can see that the speed and wavelength will going to decrease here. So I can say that option number C will be my correct option. So both the wavelength and speed is going to be decreased in this case. Now, the next question is, a ray of light is going to enter from denser to rarer medium. So the light is traveling from denser to rarer. So what is the angle of incidence called 90 degree as an angle of reflection? So this angle will be angle of reflection, critical angle, angle of deviation and angle of reflection. So when a light is traveling from denser to rarer medium, the angle of incidence that is having an angle of reflection 90 degree will be our critical angle. So critical angle is having this definition that the angle of incidence for which the angle of reflection is 90 degree will be our critical angle. Now, this is a very simple question we have. Let's move to the next question. The absolute refractive index of any medium is. So we have the two type of the refractive index, that is the relative one and the absolute one. So absolute refractive index will be always greater than 1 for any medium. It cannot came out to be less than 1, 1 or 0. So we can say that the absolute refractive index will always be greater than 1. Now the next question in this sequence is, a lens has a power of +5D, then the lens will be. So firstly, what we are given with? We are given with the power of lens. Power of lens is +5D. So what is the relation between power and focal length? The power is given by 1 upon f. Now you can calculate the focal length of the lens by 1 upon p and it will be 1 upon 5. So what will be the value? The value of the focal length is 0.2 meter. So it is positive here. You can see that the value is positive here. So the focal length will be 0.2 meter and you can see that this lens is having a positive focal length. The focal length is positive. So it will be definitely going to be your convex lens. So let's check the options here. Convex lens of focal length 0.05 meter, concave lens of focal length 0.20 meter, convex lens of focal length 0.20 meter. So it is the focal length 0.2 meter and the lens will be the convex lens. So I must say that our option number C will be correct. So this is the question which is based upon the power of the lens. Now let's see the next question in this sequence we have. The refractive index of glass is maximum 4. So the value of mu. So actually this refractive index will be given by C upon nu, and this nu will be our frequency. So you can see that the refractive index is going to be highest and is maximum for the red color, because it is our color which is having a greatest wavelength in this case. So it will be greater for the red color. Now the next question is, a real and enlarged image can be formed by. So can you tell me which mirror is going to form the real and the enlarged image? So the real image and enlarged image is obtained only in case of the concave mirror, because convex is going to give you the virtual and erect image. So I must say that the concave mirror will give you the real and enlarged image. So our option number C will be correct in this case. Now the next question in this sequence will have magnification produced by convex lens. So the magnification for the lens is simply given by the formula V upon U. This is the formula for magnification, and the convex lens is going to produce the magnification more than 1, less than 1, equal to 1, or more or less than 1. So it can produce the magnification either more than 1 or less than 1 depending upon the values of V and U. So the correct option here will be option number D. So we must say that option number D is correct. So let's move to the next question. This is a very simple question again we have. For an incident ray directed towards the center of curvature, and ray of light is incident towards the center of curvature of the spherical mirror, the reflected ray. So if a ray is going to be incident at the center of curvature, what will happen? It is going to retrace its path. So I guess here it will retrace its path. So our first option is correct in this case, because the light is going to be directed towards the center of curvature. So it is going to retrace its path. Now the next question we have is, the focal length of the spherical mirror is 20 centimeter. Now see what will be the focal length of the spherical mirror. Focal length F is 20 centimeter. Radius of the curvature of the mirror will be. Now the relation between focus and radius of curvature is this: F will be equal to R by 2. So simply R came out to be 2 into F, and 2 into 20 will give you 40 centimeters. So the radius of curvature came out to be 40 centimeter in this case. So which option is correct here? 10 centimeter, 20 centimeter, 40 and 80. So we can found here that the 40 centimeter is correct. So our option number C will be correct in this case. So simply by applying the formula F equal to R by 2, you can calculate the radius of curvature in this case. So just copy this from here. Now let's see what the next question is saying. refractive index of a medium with respect to air is mu and its value is under root 2. So you are given that refractive index of medium is under root 2. What is the critical angle between two medium? So the formula for critical angle, that is IC, will be given by sine inverse 1 upon mu. This is the formula for calculating this refractive critical angle, and we have discussed this formula in our previous lectures also. So it came out to be IC equal to sine inverse mu is under root 2. So it will be 1 upon under root 2. Now, sine is having a value of 1 upon under root 2 only at 45 degree. So I can say that sine 45 will give me the value of 1 upon under root 2. So it will be IC equal to 45 degree. So the critical angle came out to be 45 degree in this case. So what is the correct option? 30, 90, 45 and 60. So our correct option will be 45 degree. Now for solving the questions related to the critical angle, what you have to do, you have to learn the table, that is the trigonometric table, which is having a values of sine, cos, tan. So you have to learn these values so you can easily find out the value of sine 45 from this. So this is the question which is based on the critical angle we have. Now let's move to the next question in the sequence. This is a very simple question you have. What will be the color of the sky as seen from the earth if there is no atmosphere? So you can see that if there is no atmosphere, there will be no reflection of light take place. So there will be no any reflected ray which is coming to our eyes, and we cannot going to observe any color in the sky. So if there is no atmosphere, there will be no refractive index for different medium, and you can say that the color of the sky will be black. So I can say that our option number A will be correct. So the color of the sky will be black. Now let's see what is next question in this category we have. A convex lens of glass has a power of P. So let's write what is given in the question. You are given that you are given with a convex lens. Okay. Now the power in air is P. The power of this glass of this lens is having a P. If it is immersed in water, what will be the effect on the power? So one thing you should know that if you are going to immerse any lens in the water, the focal length of the lens will going to be changed. It means the focal length will going to be changed here if the power is P. So P and F are having an inverse relation. You can see that P is given by 1 upon F. So if focal length is more, the power is going to be decreased because they are showing the inverse relation, you can see. If focal length is more, the power will be reduced. So if you place the lens in water, the focal length will be increased. So what will happen in this case? In water, the focal length is going to be increased. So what will be the effect on power? The power of the lens is going to be decreased because they are showing the inverse relation. So let's check the options here. More than P, less than P, more the P for some colors and less than the P for some colors. So the power in this case will be less than P. So I must say that our option number B is correct. Option number B is correct. So just copy this solution from here. Now let's move to the next question we have. point source is located at a distance of 20 centimeter from the surface of a glass of a biconvex lens, and you are given with a lens of thickness 5 centimeter, radius of curvature 5 centimeter, refractive index of glass is 1.5 centimeter, and you have to identify the distance of the image formed by the rear surface of this lens. So firstly, I am writing what is given in the question. So what is given in the question? The question is saying that a point source is located at a distance of 20 centimeter. Okay, from the biconvex lens. The lens has a thickness of 5 centimeter. So I can write the thickness of lens is 5 centimeter. The radius of curvature is 5 centimeter. Again, the radius is 5 centimeter. And the refractive index of glass is 1.5. Refractive index is given by mu and it is 1.5. Now, we have to identify the distance of the image. So, you have to calculate V here. U is given, thickness of lens is given, radius is given and the refractive index is given, and you have to identify the image formation from the rear surface of this lens. So, you will apply a formula and try to find out the value in this case. So, let's apply the formula here. So, the formula you can apply in this case will be, it will be n dash upon s dash minus n upon s will be equal to n dash minus n upon r. So, this is the formula we are applying when the thickness of the lens is given. Now, this n dash will be our refractive index of air and this will be 1.5. These are having the values we have. Now, if I am going to apply this formula, you can see that I have to find out the image, where the image is exactly formed. So, you are given a convex lens, so you have to take the value of u, that is minus 20 centimeter according to the sign conventions we have seen. Now, this n dash will be 1 and you have to find out the s dash. Now, minus it will be u equal to minus 20, u will be s in this case. This is the image distance and this is the object distance we are taking. Now, it will be equal to 1.5 minus 1 and the radius of the curvature we have is 5 centimeter. So, 1 upon s dash came out to be 1 upon s dash plus 1 upon 20 equal to 1.5 minus 1 will give you the value 0.5. It is equal to 0.5 upon 5, and what we will get here? We will get here 1 upon s dash and that will be equal to 0.1 minus 20. Now, you can solve this equation and you can simply found that here the answer came out to be approximately 6.25. And here you have to substitute the value of n dash and here you have to substitute the value of n. So, approximately the answer came out to be 6.25. So, let's check the options here. 9.2, 6.3, 5.7 and 4 centimeters. So, you can get that approximately our answer is nearly 6.3 centimeter. So, I can say that option number B is correct. So, this is a different question that has been asked in your NTSE exam and this question is having a different formula. So, these are few of the NTSE questions we have discussed in our lecture. Now, these questions are not over here. We will continue with more NTSE questions in our next lecture. Thank you so much and have a nice day.